So let's start our next video of mathematical tools, and the rest topic that we have to cover: graph, trigonometric ratio, function and limit, differentiation, integration, vectors, log and antilog, and also we have to cover some general terms and formulas. So section 4. In section 4, we have to cover graph. As in section 1, we have covered algebra, algebraic formula. Section 2, we have covered quadratic equation and its root. Section 3, binomial theorem. Okay, let me tell you one thing. In the last video, in binomial theorem, part n c n minus 1. As I proved this is equals to n, not 1. But by mistake at last, after the proof, I wrote there by mistake 1. That is wrong. N c n minus 1 is n, not this one. So please take care of this. That had done by mistake. Sorry for that. But the n c n minus 1 is n. Next is graph. Now graph is what? A diagram showing relation between variable quantities, typically of two variables, each measure along one of a pair of axes at right angle. It's saying what? We draw a diagram between two variables quantity. And further, I will clear you what is the meaning of variable and what is the meaning of constant quantity. And for that, to measure that two variable, we take two pair of axes, two pair of axes at right angle to each other. So say x-axis and y-axis, or y-axis or z-axis at 90 degree. So we have to take two pair of axes over here. So, or a graph is also defined as a line, straight line or curve which show the variation of one quantity with respect to each other, which are interrelated with each other. Interrelated with each other, suppose say x. I have given you an example over here. Say, I think so I had done it later, but let me explain you here. Suppose say I have a quantity y is equals to 4x. Here y depend upon x, so x is a independent variable, y is a dependent variable. So graph is always floated between axes which are, these axes are right angle at each other. In general, we have three axes: x-axis with this positive direction, minus x-axis with negative direction, y-axis positive y, negative y, and z-axis which is 90 degree to this plane I'm teaching you. This is 90 degree to each other. So here it's not possible, so I'm showing it some tilt, with some tilt. This is plus z, say this is minus z, or this is plus z, this is minus z, whatever you want to do, that's fine. So first of all, variable and constant, then I will tell you this thing. First of all, we have to define what is a constant, what is a variable. A quantity whose value doesn't vary or remain fixed is called constant. For example, 5. Value of 5 is going to be 5. Value of 7 is going to be 7. 9.5 is to be 9.5, 21.8 to be 20.89. So, if I say in a question it is given to you, Suppose in an equation it is given to you a is a constant. A is a constant means there is a fixed value of a, which is say 3, 4, 5, whatever it is given. So a constant always have a fixed value, but a variable on contrary, a variable do not have a or doesn't have a fixed values. The value the quantities whose values vary and doesn't remain fixed, that is called variable. And variable are usually represented by symbol x, y, and z. Here, if we say x is a variable, so value of x can vary from 0 to 4. So x can have any value between 0, 1, 2, 3, 4, and so on up depending upon the condition. So this is the variable. So in graph, we have to take two variables for which we have to plot a graph between or plot a diagram between two axes. Suppose we have taken two axes here, x-axis and y-axis, and the all axes x, y, and z, they always are orthogonal to each other. What is the meaning of orthogonal? Means 90 degree to each other. So axes are always orthogonal or mutually perpendicular to each other. So this axes are at right angle 90 degree to each other. Along x-axis we have to take a variable quantity, and along y-axis again we have to take a variable quantity. So along this we have to take a variable quantity, along this we have again also have to take variable quantity. But which variable quantity along this and which variable quantity along this, that we will describe here. Independent variable is represented along x-axis, dependent variable represented along y-axis. As I already told you, if I have an equation of y is equals to 4x, here x is equals to 0, 1, 2, say. When x is 0, then y is equals to 0. When x is 1, then y is equals to 4. When x is 2, then y is equals to 8. So depending upon the value of x, y having the corresponding values. So x is here independent variable, but y is depending upon x. Depending upon x, it has value 0, 4, and 8. So if we plot a graph, we plot x axis, x along the x-axis and y along the y-axis, because this is dependent variable and this is independent variable, and we take independent variable along x-axis and dependent variable along y-axis. So next, difference between dependent and independent already discussed with you above. So say example is opposite to that one, x is equals to 4y. Here y is independent and x is dependent. So along x-axis we will take y and along y-axis we will take x. This is opposite of previous example. In previous example I told you that we take y is equals to 4x, and this example is stating x is equals to 4y. This both example are accurate, but in this example x is independent, y is dependent, but in this example y is independent, x is dependent. So y is an independent variable and x is a dependent variable. So when we plot a graph, so along the x-axis we take independent variable, that is y, and along x-axis we'll take dependent variable. So this is x plus origin. This point is called origin of the graph. This is minus x. This is plus y. This is minus y. So next, intercept of a line. We are going to define what? Intercept of a line and slope of a line. Intercept and slope. Intercept and slope. Then we discuss about some various graph. First of all, intercept. What is an intercept? The intercept of a line is the value, y value or x value of the point where it crosses the y-axis or x-axis. Let us describe it in detail. Suppose this is a straight line graph which is crossing the x-axis at this point and y-axis at this point. As you already know, this point is origin, and this is plus x, this is plus y, minus x, minus y. So let me explain you one thing. This is x-axis, plus x, minus x. This is point origin. We have two coordinates. This is 2D graph where we have two axes x and y. We have two coordinates, that is x and y. This is abscissa and this is ordinate, and together this is called coordinate. Along x-axis, along this axis, if any point lie on this x-axis, then value of y is always 0. So on this we have different value of x, but y is going to be 0. And on this y-axis, plus y and minus y-axis, value of x is always 0. Value of x is always 0. Y can have different value, but if y lie here, here or here, according to that y have different value, but value of x is going to be 0. So for the intercept, now we have to find intercept of x and intercept of y. If this line crosses this point on x-axis, this point, y is going to be 0. Suppose value of x is here, x or a, whatever you want to take. So this is x-intercept, means point where the graph is crossing x-axis, that is called x-intercept. Now y-intercept is what? The point where line crosses y-axis, the point where crosses the line crosses y-axis, that point is called y-intercept. Suppose instead of this we have other line like this. Now this is minus x 0. This is what? 0 minus y. This is called negative y-intercept. This is called negative x-intercept. This is plus 1 and this is negative 1. Next, slope. Now we have to define a slope. Slope is defined as ratio of the vertical change between 2 points, the rise, to the change, horizontal change between the two same points. What it's mean actually? If for a graph, this is a graph, we take 2 points, point A and point B. This is actually vertical height, this is horizontal range. If slope is what? Slope is the ratio of vertical change upon horizontal change. Along vertical we have change of y, and along horizontal we have change along x. So if we take 2 points here, point A, point B, then say this point have coordinate x1, y1, this point has coordinate x2, y2. So this point is going to be what? x1, this is going to be y1. This is going to be x2, this is going to be y2. So the change along vertical is what? This is y2, this is y1. So this y1, y2. Difference between these two. This is complete y2 and this is y1. Difference between this is this one. This is what? y2 minus y1. Similarly, this is x1, this is x2. x2 is complete up to here, x1 is complete up to here. Difference between these two is this point. This is what? x2 minus x1. So slope is what? Change along vertical, that is y2 minus y1, upon change of horizontal, that is x2 minus x1. So one formula of slope, and slope is represented by symbol small m. One formula of slope is y2 minus y1 upon x2 minus x1. There is also other formula. Suppose if in a question these points are not given, instead of that it's given that graph is making an angle of theta with x-axis. In that case it quite obvious the slope is equals to tan theta. Why so? If this is making an angle tan theta, if I take this triangle, if this angle is theta, this is also going to be theta. Why so? These two lines are parallel. This is corresponding angle. This side. So this is theta, this is theta. If we take this triangle, this is what? Tan theta is what? Perpendicular by base. This is 90 degree. This is perpendicular. P. This is base. Perpendicular is what? This distance, which is equals to this much. That is was y2 minus y1, and base is equals to this. This is what? x2 minus x1. So it's representing the same formula. So if points are not given, then slope is equals to m tan theta if theta is given to you. There is also the formula slope is equals to m dy by dx. This is actually formula from differentiation when change is very small. This I will explain you later when I discuss in detail about differentiation too. Then I will discuss with you that why dy by dx is also equals to m. Then what is this called and what is this called. There I will explain you each and every term. Now next is some various graph related to various equation. First of all, I'm going to discuss about you straight line graph. I'm giving the example of 2 to 3 equations, and after that you will try yourself for the rest. For the straight line have a general equation of y is equals to mx plus c, where m represent the slope, c represent the intercept. So there are some special cases. If c is equals to 0 means there is no intercept, then y is equals to directly equals to m is equals to y is equals to mx. Here y is directly proportional to x. What's that mean? If this is rising, this is also rising. This is decreasing, this is also decreasing. This is called direct relation. If it's appear to be like this, 1 by x, then this factor increase, the factor in denominator increase, then complete value decreases, then this also decrease. So if it increase, this decrease. If this decrease but this increase, this is called inverse relation. So for two variables which are directly proportional to each other, the graph is always a straight line passing through the origin. Straight line. So straight line passing through origin. Passing through origin. So this type of graph appear to be like this. Straight line passing through origin, making an angle theta. This is slope. So no intercept it has, neither on x-axis nor on y-axis. Next case, if y is equals to mx plus c, but here y have a positive intercept on y-axis. Positive intercept on y-axis means this appear to be like this. So on y-axis it has some value, so 0c. Here, third one, if it has a negative intercept on y-axis, then graph is from downside like this. Next, if y is equals to minus mx plus c, where minus m is negative slope, y intercept is positive on y-axis, but slope is negative, then the graph is like this. Here this is representing like this graph. Next, if y is inversely proportional to x, then this graph appear to be like this graph, this way. Next is parabola. For different parabola, there are 4 different type of parabola. This, and this. If y square equals to kx, then we have right hand side parabola. If y is equals to minus kx, then left hand side parabola. If x square equals to ky, then upward parabola like this, passing through the origin. Here, these are just passing through the region. There are different cases too. The parabola which do not pass through the region, they were the different cases with different equation with having some values. And this one, x square equals to minus kx, this is downward parabola. So I'm sending you a PDF along with this. From that you will try the graph, or you can see the graph of other equation for hyperbola, for ellipse and other so on.